So we certainly could use our calculator in order to evaluate any of those trig functions from that last example. But with some of the things that we are going to be doing later on in this chapter, we do need to know how to think about what these angles are going to be related to. So what we're about to do might seem like it's not necessary, but by the end of this chapter, you'll see why we need to have these reference angles. So when we are trying to find the trig function for an angle where the terminal side is not in the first quadrant, we're going to have to figure out these reference angles. And we'll usually use an alpha for the reference angle. And what that reference angle is it's just the positive acute angle. Whoops, that's not how you spell positive. Positive acute angle that's formed by the x-axis and the terminal side of theta. So I guess I need angle here too. So you see three examples here of finding the reference angle. So when the angle is in quadrant 2, the reference angle is formed by creating this right triangle here down to the positive x-axis. And your calculation there for that alpha is going to be 180 minus theta. You should see where that's forming the rest of a supplementary pair. Now, when you're in the third quadrant, you see that you're a little bit beyond 180 degrees, and your reference angle is going to be that extra part past 180 degrees. So you draw your reference angle there by going to the negative x-axis, and you'll do this calculation by taking your theta, your angle, and subtracting 180 degrees to figure out what that little reference angle value is. And then if your angle is in the fourth quadrant, you see that we're just shy of going all the way around to 360. So you'll calculate your alpha value by taking 360 degrees, subtracting theta, and that's going to give you the reference angle. So you'll definitely want to have those three rules with you as you try to calculate these reference angles. So in this section, we'll be using our calculator, so it's not so important that we do anything with these reference angles right now other than just calculate them. So for example 11, if we want to calculate the reference angle, 126.9 is in quadrant 2. And so to calculate the reference angle, we'll do 180 minus 126.9 degrees. And our reference angle is 53.1. Now, what's useful here is I want you to look at this. And I'm just going to do sine, cosine, and tangent because the reciprocals are going to be this, they're going to have the same observation here. If in your calculator you do sine of 126.9, you get about, I'm just going to make that 0.8. If you do the cosine of 126.9 degrees, you're looking at negative 0.6, and the tangent of 126.9 degrees is negative 1.332. Let's see what's happening with alpha. So if I do sine of this 53.1 degree angle, this reference angle, it's 0.8. What if I do cosine of 53.1? I get positive 0.6, so it must not be that I'm getting the same value, but there seems to be something happening here. Tangent of 53.1 is positive 1.332. So you should notice that the absolute value, okay, the number part for all of these is the same. Sine of the original angle and the reference angle is the same. Cosine for the reference angle and the original angle, you have the same number, different signs, And then same with tangent, same number, but the different positive and negative. So why is it that we were dealing with negatives when we were looking at 126.9? Well, go back to what's happening in the different quadrants. In quadrant 2, cosine and tangent are negative, but our alpha is always going to be an angle in quadrant 1. So you'll always get positive values for your reference angle, but not necessarily for the original angle. So let's look at this again in 250 degrees. So here, that is in quadrant 3. And so we need to figure out alpha is 250 degrees minus 180. That's our rule there. So we're looking at a 70-degree angle. So let's just do sine, cosine, and tangent using the 70-degree angle. Now, years ago, there were tables for a lot of different angles from 0 to 90, but these tables didn't always go beyond 90, and they didn't have to, because you can see this relationship between these reference angles. You can take any angle more than 90 and you can relate it back to an angle less than 90. So this was before calculators. We now have calculators, so this particular application is not useful anymore. But I do promise by the end of this chapter, there is something that you'll have to be able to do with these reference angles. All right, so sine is 70 degrees. So if we put that into the calculator, we've got 0.94. Cosine of 70 degrees is 0.34, and tangent of 70 degrees is 2.75. Now, in the first quadrant, these reference angles will always be positive. But in quadrant 3, you should have a negative sine, a negative cosine, but a positive tangent. So sine of 250 degrees is going to be negative 0.94 without even putting this into the calculator. Cosine of 250 degrees is going to be negative 0.34. And tangent of 250 degrees will be positive since tangent is positive in the third quadrant. Let's do one more of these just for good measure. If we have the angle 318.5, that is in quadrant 4. So to get our alpha, we'll do 360 degrees minus the given angle. So we're looking at an alpha, a reference angle of 41.5. So if we do sine, cosine, and tangent of these, this is going to evaluate what it would be in the first quadrant. So we're looking at 0.663, 0.749, and 0.885. When we're in quadrant 4, sine is negative, cosine is positive, and tangent is negative. So sine of 318.5 degrees will have to be negative 0.663. Cosine of 318.5 degrees will stay positive. And tangent of 318.5 degrees is going to be negative 0.885. Didn't get that negative in there yet. Negative 0.885. So using these reference angles, you can see how the sign for the different trig functions based on where you are in the coordinate plane can affect whether you're looking at a positive or negative value. And these reference angles help us determine what these trig values are as far as the absolute value of them, and then we can figure out if it should be positive or negative based on which quadrant we're in. So hang on to this knowledge as we go into our study of vectors, because we will need to come back and look at some applications with these reference angles.